I'll be giving an explanation and review of the math as presented in Animation versus Math, released by Alan Becker about 6 hours ago. So I know a little bit about math, but I don't have quite the same understanding as some other people like math majors or math students. But I'll try my best to explain at least some of the concepts that I might come across or other cool things that might show up. So here we go. And yeah, we can skip ahead or kind of fast forward through some of the parts that are pretty obvious. So yeah, this one just appears out of nowhere. He adds them together, learns addition. He's like, oh, okay. Here's a 2, different symbol. Oh, here's a 3, so on. And then here's a second digit that appears in the ones place. A 0, huh? And okay, then it's 12, 2. He learns to expand. 1, 4, 20. And he adds it all the way up to 100. Just kind of shows the vast expanse of this universe here. He's like, huh, I'm bored. Sits down. He accidentally compresses it. So it seems like tapping the equal sign here kind of compresses the numbers. A little subtraction. It's like, oh yeah, go to 98, down to 0. -1, huh? Shakes it, becomes e to the I pi. Wow, e, huh? What's e? Wow, it's animate. Why is that? Escapes off to the imaginary world or the complex world. Yeah, it becomes -1. He's like, oh, I want to get that e guy again. Okay, well, I'll just explore. -1, -3, +3. Yeah, because I guess he flipped that sign, right? Kind of cool. Tries to turn it into multiplication. Oh, here we go. Yeah. 3, he expands it. Here we got a grid-like representation of multiplication. +1 times 4. He flips, yeah, he flips it, doesn't he? So, looks like this first number is the kind of column number. Yeah. Cool. He once again taps that equal sign. Let's see. Yeah, just to compress it. So tapping the equal sign kind of compresses the number and simplifies it. Turns it to division. Here we have, it takes 3 2s to add up, or sorry, it takes 3 -2s to subtract from 6 to become 0. And this gray number is like the counter. So it becomes 3, expands it, yeah, once again. Ooh, here we get some 1s. Takes 6 -1s to add to 6 to become 0. So, yep. He gets 0, 6 over 0. And you cannot add enough zeros to become 6, so it's just infinite zeros, basically. And all these zeros are falling, but they don't reduce the number of 6s. So, yeah. I thought initially, like, when I was first watching this video, this division by 0 would become like a climax or of sort, like a climax, yeah, of the video, but it didn't actually end up happening. So we have exponentiation. 6 times 6 is 6 squared, which is 36. Yeah, it's 2, it's 8 squared, 64. He doesn't simplify it though. Then 6 minus 2 is 4, 4 squared is 16. 4 to the power of 2 plus 1, 4 to the 3. This kind of extends into the third dimension. So here we have kind of like a cube, if you could kind of visualize that. Here we have a 4-dimensional kind of thing. And it's 5th dimensional with columns, so it's here 1, 2, 3, 4, that's 1 dimension. 1, 2, 3, 4, that's another dimension. 1, 2, 3, 4 within each column, that's another dimension. So here we got 3. And then it's 1, 2, 3, 4, that's another dimension. And he extends it down, so it's 4 of those kind of, I guess, 4x4s. So yeah, you see that. He taps the equal sign, compresses it, simplifies it to 1024. Learns about different types of exponents, like negative exponents. That's a fraction. Ooh, okay. Yeah, fractional exponents, that's the square root. He simplifies it. Doesn't simplify it all the way. It becomes square root of 4, square root of 2. This is an irrational number. Square root of 1, square root of -1. Oh, I came from e to the I pi. So, okay, that's cool. So then he adds them together. This is a complex number. Oh, I times I. It's like, what is that? He scratches his head. So, yeah, I squared, that's -1. That's just a property of I. That's a kind of a defining characteristic. Here we find e to the I pi, so I times I is -1, and we saw earlier that e to the I pi is -1. So you have I times e to the I pi. He's like, oh shit, let me get out of here. He's like a kind of cornered animal. He runs away. He's like, I want to escape. The second coming kind of chucks I at e to the I pi times I. So kind of cool thing. I times I is -1. -1 times e to the I pi is going to be 1 because e to the I pi is -1. So it's all going to be, this is kind of like I to the 4th power. So he attempts to escape, but then I multiplies it, so then it becomes a real number. So he's back into the same real plane. And I guess, yeah, it simplifies a negative number. He expands himself. This is called Euler's formula. Let's see, yes. E to the ix is equal to cosine x plus I sine x. So you can read into that if you're interested. It's a really weird formula, but there's a 3 blue 1 brown video that explains it pretty nicely. It's this number. Let's see if I can find it. Yeah, this one.
One way to think about the...
So this is a good video if you want to understand this formula, and specifically in the context of kind of rotations. So throws a negative sign, hits the second coming, flips him, because negative signs kind of flip things. And then this E kind of expands itself, or what does it do? It adds a negative pi. And I think there's an error here actually, because, yeah, there should be a parentheses around the pi minus pi. It should be more like, let's see if I can graph this. Okay, well, Desmos doesn't have imaginary numbers in it, but it's still nice to kind of show what's going on. So I'm saying it should be like this, rather than e to the I pi minus pi. Because like order of operations, like multiplication happens first. So this is what they're saying, but it really should be like that. Because otherwise, this is the same thing as like, let's say, it'd be the same as e to the I pi over e to the, yeah. This is not 0. This is going to be something else. Or sorry, this is not e to the 0, which would be 1. So I'm saying all of these 3 things are equal, but this is what they mean to say. So yeah, e to the I pi, let's see. E to the I pi starts off as -1, then he evaluates to e to the 0, which is 1. So he kind of goes from, in the unit circle, from -1 to 1, which is a kind of a cool arc he goes there. He's like, oh, let's see, multiplies his speed. He flips him so that it, like, stops his momentum. Then he like catches him. Oh, then they get thrown off. It's like, okay, let's fight. And this is like a cool sequence, like a little sword fighting sequence. I gotta slow down for this. So he pulls out a 1 out of his ass. He fights. They fight with 1s. He has a -1, so -1 plus 1 equals 0, which is kind of this clash you see. They fight some more 0s. So then he expands it to like a 4, so it's like more power. So yeah, this kind of knocks him over. But if you notice, a -4 plus 1 is equal to -3, so that's kind of cool, but I don't know why this is still 0. Yeah, keeps shrinking this number ever so slightly. Then he just like duplicates his +1s. So he has 2 swords. Oh, more power. Converts it to a +2. The +2 converts it to a bow. 2 times 2. 2 times 2 is 4. So he shoots these arrows, these four arrows, I guess. So he takes that 4, converts it to a fraction. E to the I pi over 4. That's kind of like a rotation of the complex plane by 45 degrees, because pi over 4 is the same as 45 degrees. He runs off. Shoots more arrows. And he's like running hella fast while shooting arrows, which is pretty impressive, I would say. And then he multiplies himself by I. And multiplying a number by I kind of rotates it 90 degrees in the complex plane. So he kind of launches himself up there. Shoots more of these kind of arrows. Let's see. Then he discovers kind of this coordinate system. Oh, what can I do with this? Oh, imaginary numbers? The complex plane. The real plane. The real number line. Ooh. Then he makes this kind of unit circle. And then he discovers like radians. So radians, let's look at the definition. Yeah, this is the definition of a radian. You can look at that on your own time. But then it turns out you need 2 pi radians to kind of cover the entire circle. So I was like, okay, let's take this kind of 1 radian arc, or 1 radian sector, I guess. And it has a length of 1 because that's by the definition of a radian. He multiplies it. He has 2 of these arcs now. He expands it. The radius is greater. Data r equals something. R equals 5 right now. So it's 1, 2, 3, 4, 5 units. He adds 2, so now it's 7 units. Now it's 3. And then this data, he shakes it. He kind of shifts it. This is not really mathematical. This seems more to me like some creative interpretation by the artist, the animator. So yeah, this is also another creative thing, like just splitting or kind of tilting this data aside. Kind of cool though. R equals 1, division sign. So R is 1 as defined before, so that's just data equals 0. He flips it. Kind of a nitpick, but this doesn't quite align with this. Like this bar within the data doesn't really align with the kind of line in this circle. At least until here. It's like some, yeah, it's a nitpick. So then here we have data equals pi. Like, oh yeah, pi. I remember that guy. He splits it into cosine and sine because, I don't know, trig functions. And then he's like fighting with it. He makes a kind of function. He kind of draws it out. If y'all don't know what sine looks like, it's like this basically. Starts off at 0. So at time equals 0, the evaluation of sine of 0 is just 0. We see that kind of here. Although kind of weirdly enough, when we have sine of pi over 2, it should be 1, but it kind of looks to be 0. Or sorry, negative 1 over here. So that's just another nitpick, I would say. Then he starts with cosine. It goes vertical this time for some reason. Cosine of x. Let's see. Yeah, it starts off at 1 when time equals 0. Time t equals 0. So, yeah, that's kind of what we see here. Pretty accurate. Then he hits both of them at the same time. And it's like, okay, let's make it I. So, as I said before, multiply by I kind of rotates at 90 degrees. Although I don't know why cosine is kind of vertical to begin with. Then we have cosine, sine, cosine x. If you plot them both together, it kind of creates that little pattern here. And if you kind of envision this in 3D, it looks sort of like a helix, but let's see. Then he combines them. What is it? Cosine of pi plus I sine of pi. Well, that's just the Euler formula, right? We saw it from before. And then Euler's identity actually is just an application of Euler's formula, specifically when you plug in x to be pi. You can see that because cosine of x. Let's see, cosine of x. Cosine of x is just negative 1, so that's going to be negative 1. And then I times sine of x. Sine of pi is just going to be 0. So it'll be negative 1 plus 0 is equal to e to the I pi. Okay. So then he finds e to the I pi, just kind of spawns in. He's like, oh, let me get out of here, man. And he fights him with the arc. They're doing more sword fighting. Oh, this is cool. Again, they're forgetting the parentheses here. It should be e to the I times, what is it? Okay, I'll just say it. E to the I times, in parentheses, pi minus 2 pi. So then he kind of draws an arc, goes from negative 2 pi to pi, which overall would mean e to the negative I pi to e to the 0. So once again, that's going to be kind of going from negative 1 to 0. So it gets this kind of half arc here, or half circle. He does more of that. They fight. This. So then he gets like a big kind of sword number. So the swing is massive. Just sends him flying a little bit. He uses the bow a bit more. This is the Taylor expansion of E. So E Taylor expansion. No, I don't want that. Here, this is good enough. So you can look into this, but here we see e to the x. In this case, you can plug in I pi. So if you go to this kind of function, instead of x, you would use I pi, and that's kind of what we see here. there's probably another nice YouTube video about this. You can look it up. So he launches the first few terms of that Taylor expansion. See, x to the 0 over 0 factorial. That's what we see here. And then he gets to 1, 2, and so on. And then when it kind of splashes, or when it hits the actual target, it kind of expands. So 0 factorial, that's 1. I pi to the 0 power is just 1, so that's just 1. And here we get, yeah, you can kind of slow down the video and see this for yourself. Yep. 1f, he multiplies by 4 of that kind of quarter circle, creates a full circle, multiplies by pi, creates a shield. He's like, yeah, I'm better than you. Multiplies that circle by 8. Cool, sure. Let's see, we can slow this down. So then, let's see. E to the I pi is -1 times -1 is a plus, so then it's just r plus theta. So he's expanding theta. Although for some reason the radius is increasing. Although it's r plus a constant is equal to r plus a constant. So what should be happening is, like, I don't see why r should be increasing, but still is regardless. He takes the 8 divided by that. Well, 8 divided by 8 pi r squared should actually be 1 over pi r squared. So it shouldn't return back to its circle. It should be like something weird. Yeah, whatever. And then he gets kind of pulled in. This guy, he's spinning like a madman. He uses the number 7. 7 is hella sharp. I like a pointy end. Oh, this is the coolest gamer move, by the way. He like just uses the negative sign on himself just to flip him to the other side. Yeah. Goes back to Taylor expansion mode. He's shooting all these like numbers, all these terms. Oh, he's like, okay, I gotta get up here. Pole vaults himself with the 4, takes the coordinate number, uses baseball. Damn, sine wave. Kind of like a ray gun. Okay, so this guy, he's really angry now. He's like, okay, I'm gonna expand myself. I'm gonna exponentiate. Gonna, undergo exponential growth. So here, what does it do? Yeah, it's sine over cosine, that's just tangent. This is like some weird kind of function. It creates tangent. I don't understand what this thing means. I looked it up earlier. It's like in latex, it's the left harpoon arrow or something. Sure, you can probably explore that, but I also don't know what this dot means exactly, if it has any meaning in math. But my guess is just it creates a function. So he gets a constant loaded. This whole army of e's, they keep growing themselves. So these are tangent curves. Tangent looks like this. So yeah, that looks pretty accurate. And we saw earlier, this function was just tangent. So he's launching tangents. Tangent collides with e to the I pi, turns it to 0. I'm not sure why that's the case, because if you like do f of -1, for example, that's just kind of arbitrary. Oh wait, it was actually 9. Okay, so yeah, I don't know why that's happening. And then even if you plug in like e to the x, it's some bogus thing. You can't really see it. Maybe yeah, actually I don't know why this tangent of x is kind of like this is like an antidote to e to the I pi. So he's launching it, shooting him. Yeah. And then for some reason this thing kind of expands this kind of domain. So then he shoots, creates a line. He adds pi, so the angle of this line is going from 0 to pi. So yeah, he gets that plus sign to the pi. Kind of cool. So then this whole army of Taylor expansion mode kind of e's to show up. He's shooting them. This whole swarm. It's like an alien invasion. Faster. He's just spamming that shit. Okay, here we go. And he just adds 7i, which goes up like vertically 7 units in this complex kind of plane. Shooting it, he takes to infinity. This guy ain't gonna die yet. He gets this kind of infinite cannon. I don't know the mathematical reason behind this. Like, well, okay, it's just cool, I guess. Like, a function taking infinity, yeah, that's gonna kill everything. And then, yeah, that... Yeah, they get absolutely annihilated. And then here, I didn't really understand this. This is like linear algebra or something. Yeah, so you can look up linear algebra, spans, whatnot, and it's span. So that's what it is. And I'm guessing x1, x2, those are like the basis vectors for this, whatever plane this is. Oh, this is the equal sign, okay. Yeah, okay. So these are basis vectors. Although, I think this is just like some artistic thing. There's not really a connection here, maybe. So he escapes. He's like, oh my god, I'm about to die. Luckily they have 4 of them here. Even one of them. You know what, I would have had like maybe a couple of me just like, you know, stashed away in the complex plane if I were E. So Taylor expansion, Euler's formula. Expands sine of, yeah, sine of pi. That can be expanded. So this is like the exponential form of sine of x. Let's see. Yep. And the derivations, you can probably look them up on your own too. This, what is that? That's the Taylor expansion of cosine of x. Cosine of x, Taylor. Let's see. Yeah, here we go. So instead of x, they use, what is it? Something else. They use pi. Yeah, pi here. Pi goes in there. So pi to the 2n. And they use parentheses here. Nice. Let's see. This is some kind of identity. It's saying I pi is equal to whatever this power is. So we could say pi is equal to 2I times log of, or the natural log of that fraction. So let's see. Pi equals 2I natural log of this fraction. Wait, what was it? Oh, 1 minus I. Yeah. And then, yeah, someone already asked it before, but that's how you can prove it. You can also look at stack exchange. Yeah, they have some nice proofs. Looks like it involves, Wait, that's the question. The answer. Okay, yeah, you multiply by the conjugate, you simplify it, becomes negative I, and then, yeah, it just looks nice. Okay, cool. So that's that identity. And in general, for the rest of these identities that show up, you can just kind of, probably just did what I did, just kind of plug in the value online, or you can even ask ChatGPT, but yeah, maybe ask GPT-4, that's going to be more accurate. So yeah, it's kind of getting this whole mech build-up scene. I imagine you can make a whole video about this. I'm not going to go through all of it. He shoots him, he blocks it. The limit goes from 1 to infinity because they're all kind of compounding to infinity. Creates this integral sign. I don't really understand what these kind of things mean on the side. Let me think. I guess, okay, these are constants. So like e to the, this can be taken out of the integral, so it's to the left of it. I don't know the significance of this, but someone else can explore that. And also, cool thing, this integral sign, like it goes from the what? It goes from like a tangent, right? This is like a tangent. It gets compressed, and those tangents, if you saw earlier, they kind of look like integral signs, if you kind of squint hard enough. Yeah, kind of. So yeah, he's got this god staff, tiny screen. They fight. Oh my god, he's getting destroyed. This guy has like an arm cannon plus like a sword. It's so cool. A spear. Oh my god. What was that? He held up like his arc. Yeah. Damn. Gets absolutely launched. And it's like, okay, well, let me come up with something. He goes up 9 units vertically. Expand, keeps going up. Summons all his minions. And then he creates this massive cannon. Oh, there's fire in this mathematical world, it looks like. And yeah, he just gets, ooh. Ooh. Just gets cut. Okay, I'll set the radius to 100. Down. Massive cannon coming in. Blam. Okay. This guy runs away. He's like, oh, let me chase this guy. He gets a circle, multiplies his velocity by like 82,794. Gets launched by that cannon. Chases after him. Explodes. Escapes into the complex or imaginary world, it looks like. That's why everything's flipped. And why everything is rotated by 90 degrees once again. And then, oh shit, everything's getting kind of obliterated. It gets cracked over. Here we see more negative numbers, or rather imaginary numbers. So this is going to be like 2i or something. This is going to be something else. Oh shit, let me save you. Plus 5. Why would plus 5? I guess this is still kind of like some real world stuff. So adding plus 5 would move to the right, plus 5. Multiplies by I, so you escape into the other portal, the other world, the real world. It's like, oh, hello, hi. Yeah, I need to ask you something. Oh, wow, that was a lot of definite instruction. Yeah, thanks. Okay, let me help you, huh? Okay, yeah, so I need something. I need to get out of here, you know. Do you understand? Okay, exit, you know, English, huh? Even though this is a mathematical creature, I hope you understand English. Exit. Oh, yeah, okay, I know where that is. Okay, let's go to the imaginary world. Not that one. Let's go to the real world. Let me show you how this works. Okay, because what? Because I to the 4th power is just going to be 1. So he ends up back to where he was. It's like, oh, okay, I didn't need that. I want to escape out of here, not just go back to where I came from. Okay, let's get this function, this weapon of mass destruction. Actually, let's extract it. Let's get this kind of thing over here. Use the IPy. Okay, just stand in there. Let me tail expand myself. Let me convert that factorial to the gamma function. So this is what the gamma function looks like. Yeah, that's the definition. Well, the Wikipedia page kind of explains it decently well. So, turns out if you evaluate this integral, it kind of ends up being the same thing as this thing over here. So, what was it? N factorial is equal to gamma of n plus 1, which if you add 1 to the arguments of both sides, then you get gamma of n plus 1 equals n factorial, which is, yeah, that's correct. He uses even numbers. This part, I didn't quite understand. I think it has something to do with the gamma distribution, maybe? Let's see. Something with the 2n. Well, I'm not sure, but someone else can look for this. Then he kind of creates this portal for him. And he's like, okay, well, see ya. Multiplied by someone with a math major could probably better explain this. Yep. Evaluates, becomes a -1, gets sent off to a different dimension. And then, yeah, he's not alone, actually. He has friends. So, he has Z. Not Xi Jinping, or more like the letter. That's what we want. From Wikipedia. So, in math, what does that mean? We want the lowercase. So, yeah, these are all the different ways you can find G or Z. That's phi, that's the golden ratio. That's another important constant. Shows up everywhere. It's also like flux in physics, maybe. And then delta math symbol. Let's see, what does that mean? Uppercase. No, we want lowercase. So these are all the uses. Probably like the Kronecker delta, that's what I'm most familiar with. And then we get this like little giant in the figure. Or huge giant. It's Aleph. Aleph null. That's what you can. Okay, actually we don't want. It's not even Aleph null, it's just Aleph. And in math that kind of represents cardinal numbers. Or like numbers beyond infinity. So, or numbers beyond. Yeah, it's just infinity. Like Vsauce made a nice video about this. Let's see. How to count past infinity.
Hey Vsauce, Michael here. What is the biggest number you can think of?
Yeah, and then what does he come up with? Oh, here we go. Aleph null. Yeah. So you can watch that video, and then it kind of run away, d plus end, and yeah, that's my analysis of Alan Becker's animation versus math. Although apparently, what was it? His lead animator kind of made it all So hope you enjoyed my analysis of this. I didn't understand everything, especially like that last part, especially, and also that integral earlier. But I hope you enjoyed my analysis. All right, thank you.